In 2020, I was working on a merchant detail screen. The plan was simple, it's just a basic shopping feature where user can add an item to the cart, update its quantity, or even removing it from the cart. But it didn't go as planned. I faced a performance issue. So the problem was every time the user tried to add, update, or remove items from the cart, the screen was freezing for more than a second. I didn't know what's going on. I didn't know where to begin. All I have is the freezing happens in merchant detail screen. Unlike any errors that I had, usually I use console.log to debug what's going on with my application. Maybe it's data malformed from the backend, or maybe the backend didn't respond properly, or is it because I forgot to pass data to my component? But performance issue? I don't know what I should put in my console.log. Back then I didn't know about profiler, so I was just lost in the dark. So I began to do a little research about performance issue in React Native, and I found several solutions. The first one, maybe the simplest one, is you have to optimize your flat list, or you use several props to control how many components that you want to render, how much is the height. I did apply the solution, but it didn't help so much. The freezing time is still there for more than a second. It is a huge performance issue. Today I want to replicate what I had back then, and I want to show you what or how I implement the solution in order to eliminate the performance issue. But I want you to know that if you have a problem with your performance, make sure to do a deep digging to your application, because my solution doesn't always work with the performance issue that you might have. So this one is specific for eliminating unnecessary re-renders. So unless your performance issue is caused by unnecessary renders, you can try this solution. But other than that, please make sure you do your own research first before applying my solution. And the solution that I am about to do is actually related with my previous video when I talk about how to use or when to use memo, use callback, and memo from React. If you want to take a look for a deep understanding, please check it out. I'll leave the link down below. I already created a screen or a prototype that's similar with what I had in 2020. It was just this merchant detail screen. We have two main sections. The first one on the top, we have merchant information. There are merchant name, merchant distance, merchant estimated delivery time, merchant profile, merchant banner, and a back button. And the bottom section, we have two main lists. The first one is the category list, and the second one is the product list on each category item. And the last one is the cart component. The problem is happening whenever a user takes an action. For example, adding an item to the cart, the screen was freezing. Removing item from the cart, again freezing. Or even changing the quantity. The problem is I cannot replicate the freezing moment. Maybe because React Native has changed a lot with the new architecture and stuff. Also the community's libraries improved so much, so it helped us to maintain a good performance in our application. What's left for us to see, or indicator that can tell us whether my solution works or not, is by using a render counter. The render counter can be created by using useref hook. So the problem now is, how do we know which component that re-render every time we change a state, whenever we update the state of our cart component? There are two methods. The first method is by using profiler. Back then I didn't know about profiler, so I didn't use this solution, but basically with profiler you can highlight any component that is being re-rendered every time you change a state. It will tell you which component by highlighting in some boxes. And the second method is by using the useref hook. You create a useref, you give initial value as a number, maybe 0, and then you can increment that number in your component, so it's gonna be reactive on every state changes. So in my experience, I only use the second method, but today let's try the first method. We're gonna open the GS debugger and see how to use profiler to highlight any components that is being re-rendered every time we change a state. Since we're using Expo, we can press J in our terminal to open debugger. Or you can open developer menu first and select OpenGS debugger. Browser opened, let's go to Components tab Click on this gear icon settings, and then select highlight updates when components render. Now let's go back to our emulator and we can try to change state. For example, I want to add an item. See the flickering? Those indicating that the component rendered when we add an item to the cart. If we try again, the whole component rendered every time I try to update the cart state, updating the quantity, even removing an item. All of the component rendered. This is bad. I don't want the merchant information section to be rendered whenever user try to modify the cart state. This is the problem that caused my performance issue back then. So how do we isolate merchant information section from the cart state? Let's go to merchant information section component, which is going to be merchant header. The first step to memoize our component is to wrap it with memo. I'm going to move export default down here, and let's import memo from React and wrap our merchant header with memo. Let's try to change a state. For example, I want to add an item to the cart. I can increase the quantity or even decrease the quantity. As you can see, there's no more boxes inside merchant information component, which means we already memoized the component. Let's move on to the next component. Do we need to re-render all of these items whenever we try to add an item to the cart, increasing it or decreasing the quantity, or even removing it from the cart? Because all of those actions has the same pattern. It renders all of the items again. It's gonna be heavy pretty quick, because if you have 100 items, all of them are going to be re-rendered. So let's try to optimize the product list component. We're going to use the second method, which is the useRef method. We're going to create render count and put it in our component to see how many times the component rendered. First, let's optimize the category component. Let's go to our category component. Let's render category, category tile, and let's create our useRef hook. It's going to be cons render count useRef. Initial value is going to be 0, and let's add it to our title. Render count dot current plus plus. Save. Now let's try to change the cart state. The counter keeps increasing all the way to the bottom. What if the user wants to add an item up to 10 or even 20 times? Do we need to keep re-rendering for them, or we can wait until they get into the final count, and then we're gonna update the global state. Now let's see what happens inside the product component. We can go to render product tile, and let's I already created the counter, so let's try to render it. Render dot counter dot current plus plus. Now if we try to change the state, it's going to update all of our product list. So let's try to be a user. For example, what if I want to buy 10 of tuna? I'm gonna press add an item to the cart, and I would increase the quantity until 10. Or even, what if I change my mind and I decided to buy only 5 items? Oops. Now looking at the render count, it renders our list for 25 times. This is a lot. So what if we do not render or update the global state until users satisfied with their decision? So until they get to the final decision, which is 5, we're going to update the global state right after the final decision, which is 5 instead of 10 and then 9, 8, 7, 6. When I did my research, I found these terms called the bounds. So whenever a state is still changing, we're not going to run some kind of function. In this case, we're updating our card state. So let's wait for the quantity state to be settled for maybe like milliseconds, half seconds, or even 300 milliseconds, and then we're going to update our global state, which is our card state. What we're gonna do, we're gonna create a use state to keep track of the quantity of the current item. Const temporary quantity, set use state. The first value is gonna be 0 for now, and let's try to change it here, and let's create a function. Reduce quantity, temporary quantity, set current -1, create another for increasing the quantity, +1. Now let's replace it with our new function. Let's see what happens if we now try to increase our temporary quantity. It only affects a single item, not all of the other items. Now we can add to any amount without affecting other component, and whenever we're done, for example here, we're just going to call the global state again, in which it's gonna render all of the other components, including our category list. Since we're going to update the global states once the quantity is settled, we're going to modify how we update our quantity in our global state. I'm going to create a placeholder so that you can have an idea of how the bounds work. So let's import and use effect. We're going to watch our quantity, temporary quantity, and let's create a timeout. Let's say half second, and we're going to call our own update function that we are going to create later. We are going to pass our temporary quantity here. Let's create a cleanup function. It's going to be return clear timeout debounce. So I'm going to update our global state function. I have added a new action type called update in our global card state. So instead of manually increment or decrement the quantity value, we just assign the new value directly to our quantity property. In our category tile, I already created on quantity update. It receives a quantity as a number and we pass it to our global card state function. This function is passed down to our product tile component. In our product tile component, the function is being used in our debounce function. So whenever the temporary quantity isn't being updated for the last 500 milliseconds, then we are going to call our global card state function. I am going to try to add an item to the cart. Now I want to add 10 more items to the first component. The first component is going to change the render count from 4 to 15. Because since I am going to add 10 more items, it's going to add 10 more render counts. It's going to be 14. But after we have done our action, we are going to call the global card state function to update the quantity. So this will trigger the re-render once again. So it's coming from 14 to 15. While the rest of the items is going to be 5 render count because they only react on the global card state changes. Let's see it in action. This means we are successfully isolate our component from the rest of the list. How do we know if we do actually improve the performance? Well, let's see some numbers. First, let's go back to our previous version, the unimproved version. So this one, I use back our unsubtract and unadd also the quantity directly from our global car state. Now let's go to our profiler and make sure you are in profiler tab. Before doing anything, let's start profiling by clicking on this button. Now let's try to add items to our cart. For example, I want to add 10 items to this one. Now let's stop the profiler, and now you could see this bar gives information about render time, the layout effects, and all of the children or parent components. As you can see, the yellow bars usually have more than 150 milliseconds render time. Now let's take a look at the improved version. This is the improved version of this project. So let's try again. We're going to record or start profiling. We're going to add an item, edit 10 more items, and it will stop the profiling. Look at these bars. It barely touches 50 milliseconds. There's only 2 high yellow bars. The rest is blue and it's low. So it is a really noticeable performance improvement. This is what saved my career in my first job. Back then, even the unimproved version is causing the freezing time, but now it works just fine because React Native evolves. But I tell you, this is the solution that I had back then. In our next case, my second case, which happened to me in my senior year of being a professional developer in React Native, I actually encountered the same problem. This one is going to be more complex. It has more components, and as a spoiler, we're going to manage 3 different type of inputs in single item. So we are going to isolate the component to eliminate unnecessary re-renders. Compared to this one, we only have 1 input.